Meteorologist Brett Anderson here in the 1011 Weather Center. We're going to be doing our 1011 Weather Workshop coming up in about a minute or so, and today's topic will be clouds. So just to hold on and we'll make sure everything's working here, and we'll start today's lesson on clouds. And good afternoon. Welcome to another 1011 Now Weather Workshop. We've been doing this now for 3-4 weeks now, I believe, and today we're talking about clouds. If you remember last Thursday, we talked about the water cycle, so we're going to kind of try to talk more about how the clouds develop from the water, the types of clouds, and cloud heights. There's low clouds, mid clouds, high-level clouds, if you will. And again, we are going to be talking about that. But once again, thanks for joining us. Thanks to Allo, our partner in this 1011 Weather Workshop, and glad to have you aboard. So, of course, we're going to start off with all the types of clouds here. And as I mentioned, you have the low clouds, and you'll be able to see that on the bottom of the screen. It's kind of by the 1011 Now weather. You can see the low clouds, and there's stratocumulus, there's cumulus, as well as stratus, and there's nimbostratus as well. And then you start getting into the mid-level clouds, and those are altostratus and altocumulus clouds. Again, we're going to go into more detail on these in just a little bit. And then you have the high-level clouds, and most of these are usually composed of ice. You have the cirrus clouds, cirrocumulus, and cirrostratus. You can see how they kind of look. And then, of course, you have the cumulonimbus, the big thunderstorm clouds, and they basically stretch from low levels all the way into the upper levels of the atmosphere. Those are the vertical clouds, the vertical development. So again, you'll also notice on this page we have an airplane here, a jet, and it usually flies at the altitude of where the high clouds are. But you know, even some of the high clouds can be higher than where, if you've ever been in an airplane, you're usually looking down at the clouds. But there are times where you can kind of go through the high cirrus clouds, or maybe even the high cirrus clouds and cirrostratus are even a little bit higher than the jet. And most of the time when you're in a jet, you're flying from about 30,000 to 35,000 feet. So again, we'll go into more detail on that. So that's just kind of a look at the types of clouds. And again, we'll be going into more details. So basically, we'll talk about the cirrus clouds first. And they're usually the thin, white, wispy clouds. And again, feathery, hair-like patches. You've seen these in the sky before, and they're usually in the high atmosphere, and they're mostly made of ice crystals. They're so high up, the atmosphere is very cold, so of course it's more ice crystals rather than water droplets. And as you see the wind blows, the wind is a little bit higher up there sometimes, and it kind of blows them into long streams, so they look like streaks. And cirrus is Latin. That refers to a lock of hair, so it kind of looks like a lock of hair, if you will, when they named these clouds many years ago. So those are the cirrus clouds. And then we're going to drop all the way down to stratus clouds. Now, there are cirrostratus clouds. Again, we'll talk a little bit more about that. But let's just focus on stratus clouds. These are generally the low-level clouds we'll talk about first. And these are these low gray clouds, kind of a uniform low-level grayish clouds that cover the entire sky. And fog is a type of stratus cloud. So when it's foggy, when you're walking around in the fog, basically you are in that cloud. Now, stratus clouds usually don't produce any kind of precipitation, although it can produce a little bit of drizzle, very, very light drizzle, or maybe flurries if it's cold enough, but it usually doesn't produce any kind of heavy precipitation like the snow that we're seeing today does not come from stratus clouds. Flurries, yes, maybe some drizzle, but again, usually heavy, widespread precipitation does not come from the stratus clouds. And stratus, again, in Latin means layer, so layers. All right, we'll move on now to the nimbostratus clouds. And again, this is more of the precipitation maker. They're dense, they're dark gray, they're kind of bluish, they're very wet-looking clouds. You certainly see continuous precipitation, or you can see a steadier precipitation from these clouds, whether it be rain, whether it be snow. And they're basically a low-level cloud. They can build into the mid-levels. And nimbus refers to rain clouds and is Latin for the dark cloud. And by the way, I actually took this picture in February with a holiday travel vacation trip. We went to the Panama Canal, and I actually took this picture as we were coming out of the Panama Canal on the Atlantic side, and there was some showers developing. You can see that there's rain there, so that's the nimbus. Doesn't that look cool, Brandon? Brandon Rector's
really cool.
in the house. You're very impressed, aren't you?
I am very impressed.
Thank you.
That's a cool shot.
It was a lot of fun. It was very warm and humid that day, but it was a lot of fun. Okay, enough about me. We're here to learn. All right, cumulus clouds. Now these are those type of clouds that you can look at, kind of a cotton ball like clouds with sharp outlines. There's some examples there. They're white or a kind of a light gray in color. Kind of depends if the sun's on it. Usually if the sun is obscured, they look more gray-like, but if there's a sunny day like the picture shows here, they're a little more on the white side. Now, they're fair weather cumulus clouds. The day can be nice, and just with a little bit of daytime heating, these clouds can kind of pop up. Now, sometimes if there's enough updrafts of motion, air moving upwards, they can kind of converge into towering cumulus, the kind of clouds that build up higher and higher. Not necessarily thunderstorm clouds, but just what we call the towering cumulus. And again, cumulus means pile in Latin, referring to their heaped and lumpy nature. So that's what cumulus clouds, and of course we see all kinds of cumulus clouds around here, especially in the spring and the summer and the fall. Now we're going to go back into the mid-level clouds. Remember, we talked about alto being the mid-level, and these are alto cumulus clouds. And they kind of look like cumulus clouds like we just talked about, but they're a little bit smaller. They're rounded, kind of rolled, grayish, white, puffy clouds. Again, they're at the mid-levels. Remember, mid-level clouds are usually from about 6,000 feet to 20,000 feet above the ground. And these middle clouds, alto cumulus clouds, are mainly water droplets, but sometimes certainly can be made out of ice crystals. There's also the alto stratus clouds, which is more of a sheet-like layer. Remember, we talked about stratus, but there are an alto stratus type cloud in the the mid-levels of the atmosphere. So again, the top is usually white with a darker base. Now it's about the size of your thumb. If you hold it up to the sky and it kind of covers one of those clouds, it's kind of how we refer to the alto cumulus clouds. And again, sometimes there's a little bit of blue sky in between. Now I mention that because, once again, when you go into the high-level clouds, there are what we call cirrocumulus clouds, and they're primarily made of ice crystals, but the cirrocumulus clouds, they are also kind of lumpy looking, but they're very small. They're even smaller than the alto cumulus clouds. So, and they almost kind of look like fish scales. We don't see a lot of them around here all the time. It's somewhat more of a rare cloud, but it does happen. So if you ever see little tiny, like bumpy clouds, and they're very small, maybe look like fish scales, scales on a fish, those are the cirrocumulus clouds. All right, I want to talk a little about, this was a picture my wife took last weekend, and this is clouds at sunset, clouds at sunrise, and this is actually showing some cirrostratus clouds. You see the sun kind of shining through, but it's not clear. Those are the cirrostratus clouds. Cirrostratus clouds, cirrus clouds are usually thin enough for the sun to shine through, or what it looks kind of like filtered sunshine. It's not like a beautiful sunny day, it's kind of filtered sunshine. And then you'll notice again some of the darker clouds there that are kind of obscuring the top part of the sun. Those are the alto stratus clouds. So those are the mid-level clouds, the clouds that you can see the sun through. Those are the cirrostratus clouds. So that's just another example there of how the sun may look when you have these type of clouds. Also, a lot of times it's the mid-level and the high-level clouds that give us the pretty sunrises and the pretty sunsets, because as the sun sets, the long-wave radiation, the orange and the reds and the pinks in the color spectrum actually start to get scattered by the atmospheric particles, so that's why we tend to see more red. And of course, when you have those type of clouds around, it enhances that. All right, now we're going to talk about the cumulonimbus, and these are the ones that eventually develop into thunderstorms. These are the vertical clouds. These are the ones that can start low in the atmosphere and then build all the way up high into the atmosphere. And basically tall convective clouds with a dark base consisting of water droplets, but also ice, because there is ice particles in there. Of course, hail can develop. It does contain all forms of even precipitation, even snow, sometimes in these cumulonimbus clouds. Now, the upper winds will blow the particles downwind, creating the anvil. So a lot of times you see these clouds build up, and then they kind of stretch out at the top and kind of fan out. That is the anvil, and that is usually the upper level winds pushing it over as the winds increase as you go up into altitude. So again, those are cumulonimbus clouds, and we see those a lot around here as well. And that being said, one of the things we like to talk about, because when we have thunderstorms, we certainly can have severe thunderstorms. So other types of clouds that we may see from the thunderstorms is the wall cloud. Now, the wall cloud may indicate a possible tornado. It's basically a very abrupt lowering from the main cloud base. It's usually rotating. You can actually sit in there spinning, because remember, it's basically a cyclone. It's a low pressure system. So basically, it's on a vertical axis, and of course, it should be monitored for rotation and or the vertical development. Now, again, this is just a wall cloud. There's no tornado here, but a lot of times this is a precursor to a possible tornado. Now, there are other types of clouds that we see with thunderstorms. One is the shelf cloud. We've already talked about the wall cloud, but a lot of times the shelf cloud can actually look like a wall cloud, and some of these shelf clouds can actually look very scary and very ominous, if you will. Now, the shelf clouds don't produce tornadoes, but they may be indicating some higher wind gusts with heavy rain. So the shelf cloud will look like a low horizontal wedge-shaped cloud that spans across the horizon. It's usually associated with a line of thunderstorms, and usually the damaging winds can follow. Not all the time, but the winds are usually on the gusty side once this shelf cloud moves through the area, and then it usually is followed by heavy rain. These are the type of low shelf clouds that kind of stretch across the sky. You can look at them one end of the sky to the other end of the sky. That is a shelf cloud, and it's usually moving pretty fast. And yes, it does look kind of a scary cloud. It's an updraft, so these clouds are forming, and then the downdraft on the other side of that gives us the wind and the rain. Of course, we talked about the wall cloud. It's an isolated cloud lowering attached to a rain-free base. It's smaller and a little more compact than a shelf cloud. Remember, the shelf cloud is long. The wall cloud is usually a smaller area, and it will rotate, of course, and sometimes rotating wall clouds precede the possibility of tornadoes. All right, so mammatus clouds, this is something also we see associated with thunderstorms, typically severe thunderstorms, but not necessarily all the time. What tends to happen, sometimes especially after a storm, it can sometimes happen before as well. We see these lumpy-looking clouds, mammatus clouds, pouches, rounded, smooth, pouch-like clouds. They usually form on the underside of the anvil. Remember, we talked about that anvil. It's the one that stretches out from the top of the big thunderstorm. So sometimes it's very pouchy looking. It kind of looks like they're falling. And they often accompany severe weather, as I mentioned, but usually do not produce severe weather. These clouds don't produce severe weather. They're just usually after the severe weather. And they're developed, they're somewhat rare, but it's a rare occurrence of clouds forming in sinking air. Remember, usually we talk about clouds forming with rising air. Well, because it's so turbulent that we actually, once the air starts to sink, it actually can make clouds. So that's why it's a rare occurrence of clouds forming in sinking air. Now, here's another scary-looking cloud, and we don't see these all the time, but we certainly have seen these, and these are called the undulatus asperatus clouds. What do you think of that, Brandon?
Those are cool. Those are cool.
Yeah, they look really scary. They look you can see how they look, and yes, we do see these. Now, basically, they tend to form following convective thunderstorm activity, but usually dissipate without forming a storm themselves. Sometimes they can produce some rain showers from that, and they do look really scary, but they basically are harmless clouds in most cases. The name translates to agitated waves. They look very turbulent. It's a very turbulent, mean-looking sky when we see these, also known as the asperatus clouds. So we do see those, so you don't need to fear them. They look scary, but you don't need to fear them. Now, if you remember last week, we did talk about the water cycle, and we'll just kind of go through this quickly because we want to get to evaporation. This is when the clouds start to form. So we start to see the evaporation, not just from the ocean, but evaporation from lakes, the streams, transpiration from the trees, the plants, from lakes, from rivers, from the ground. So basically, we get the evaporation. The water vapor will lift. It eventually cools as you go higher into the atmosphere. That causes condensation, which means cloud development. And eventually, as enough droplets collect and the rain droplets get heavier and heavier, it starts to form precipitation or snow as well, depending on the temperature. So what is a cloud? Well, a cloud is actually, there is actually some dirt in it. There's dust, salt particles in the air, and they're called the condensation nuclei. We'll talk more about that. Now, keep in mind what I'm showing you here, the dirt particles are very, very small. You can't even see them with your eye. I'm just kind of blowing them up for you to see. But again, these are usually microscopic. So as you know, the air rises, and as it rises, the air cools. So what tends to happen, of course, is we start to see the water vapor, which is in gas form, become liquid. But that liquid needs something to attach to. It just can't form out of thin air. It needs something to attach to. So what does it do? These water droplets attach to these dust particles, these dirt particles, these salt particles. So that's why it's called the condensation nuclei. So now you have all these water droplets condensing on these dirt particles in the sky. And of course, eventually you see millions of these droplets form, and that's when you start seeing the cloud. Remember, a cloud is just millions and millions of tiny little water droplets or ice crystals, depending on the temperature. So that is basically what a cloud is. Yes, there's some dirt in there. There's salt, there's dust. So we had a question last week if you could eat a cloud. Well, you can, but Brandon, it might be a little dirty. Might be a little bit of dust in there.
Could be.
All right. Brandon's working on, it's snowing outside. Brandon's excited about the snowfall, and he's getting things ready. So he's just humoring me here. Okay, so some people have asked, how heavy is a cloud? Well, we'll just talk about, clouds can be different pounds or different weights, if you will. Now, the average cumulus cloud that we see actually weighs over 1 million pounds. So there's a lot of tiny water droplets, and it's floating up there, million pounds. What is that? That's about the same as 100 elephants. That's impressive.
That is very impressive.
That's right. So just kind of the standard cumulus cloud. So that's pretty much today's presentation. I would like to give a big thanks to meteorologist Jan Ryherd for creating the graphics and also doing the research for helping us out, not only for my presentation, but Ken's presentation as well. She's been working very hard in the background doing the research and, of course, creating these graphics. So I think we're ready to answer some questions here. What do we have? Do we have anything going on, Brandon?
There's been a few questions. I think we kind of answered some of them as we went along.
All right.
But we can maybe do a little recap here
Yes,
in case somebody maybe joined late and you had already answered that question.
Exactly.
But Aiden from Ceresco wanting to know, why do storm clouds form on seemingly nice days?
And who was that again?
Aiden
from Ceresco, asking why it seems like storm clouds can develop on a nice day. And that's just, that sometimes happens. You have nice weather, but all of a sudden, as we've talked about in these past episodes, these past workshops, you start having the conditions developing. You see the air moving in a horizontal area, and then you start getting the updrafts. That's, again, rising air. The sun is heating the ground usually, and then you start getting updrafts. So you start seeing all of that water vapor condense into clouds. And if the updrafts are strong enough, we start to see the vertical clouds. Again, remember the cumulonimbus clouds. start to form. You can see them developing, and then that air continues to push all those clouds up, and more moisture starts to develop, more raindrops, sometimes hail, sometimes snow, and then out of the blue you have a thunderstorm. So it is a process, and yes, it can be a beautiful day, but it can turn stormy all of a sudden. Now, sometimes this happens because of a strong cold front. A cold front will give you lift, meaning that it's forcing that air upward, which again condenses water droplets attaching to the nuclei, the dirt, and then all of a sudden you have clouds and more moisture, and eventually all the water droplets get too heavy, they form rain, and then you have rain or possibly hail, depending on the severity of the storm system. What else do we have?
Oh, let's see here. Allison wants to know, how do you name clouds? How these clouds gotten their name, basically.
Well, the clouds were named a long time ago. A lot of scientists and people used the language of Latin, and so a lot of scientific things were named using Latin words. So the cumulonimbus is actually Latin. So and it was kind of used to how to describe it. For example, we'll go to the stratus cloud, maybe the nimbostratus cloud, because that is talking about why it's called the nimbostratus cloud. And we'll get to that point, and the reason why is because nimbus refers to rain clouds and is Latin for dark clouds. So basically a lot of these clouds were named a long time ago using Latin, because we have languages all over the world, different languages, but a lot of the scientists back in the day all knew Latin. So it was trying to use a language that everyone could understand around the world in terms of the scientific names, scientific processes, and of course the clouds. So hopefully that answered your question. Most of these things are named in Latin.
Holly would like to know, why do you see some clouds in certain areas, not in others? You mentioned for a couple of the cloud types that we do not see them much around here.
Well, it's kind of like the cumulus clouds, if you will. It's basically because you have rising air. And we'll go to the cumulus clouds here, kind of check those out. On a day like that, you have the cumulus clouds where the air is rising, it cools and condenses, it forms a little patchy clouds. But and then some of the areas you actually have some sinking air, so that's why the clouds don't form. So it's just these tiny little updrafts developing, so that's why there's some areas where we have clouds and some areas where we still have blue clouds, or blue skies, basically. So that's why we have scattered clouds sometimes. Now, obviously, if you have a lot of moisture and maybe you have a lifting mechanism like a warm front or a cold front, and you've got a lot of moisture available, then you see clouds across the entire sky. And again, if there's enough and the nimbostratus clouds form, you have something like today. You have the snow falling or the rain falling. So it all kind of depends on what kind of weather system is in the area.
Okay. Jenny would like to know, are there specific clouds associated with each season?
We can have, that was Jenny, right?
Yes.
Wants to know if there's specific cloud types that we can see maybe at different points, different times of the year. Now, obviously, the cumulonimbus clouds we're going to primarily see in the spring, the summer, and the fall. Sometimes we can see them in the winter, but they're more common this time of year into the summer. This is when we start to see the severe thunderstorms. Again, that is because we have more intense heating, we have strong cold fronts, and they can force that lift up, they can force that air up, and that's why we can have the big thunderstorms. Now, again, you can have all types of clouds. Fog is a little more common in the fall, winter, and spring, and that is mainly due to some of the longer nights that we have, so that allows for the air to cool, and then the moisture in the air condenses into fog. So a lot of times winter is a cloudier period. Stratus clouds, a lot of those days where it's just cloudy and gray, doesn't look very nice, you want to see the sun, is more common in late fall, winter, as well as maybe early spring. We do certainly see a lot more sunshine as we head into the summer months.
You've talked a little bit about this, but just as a recap, Charity wants to know, how does dust get into the cloud?
Well, Charity
Yes.
wants to know how dust can get into the sky, and allow for those water droplets to condense on that? Well, there are dust storms. Every time you see dust blowing, that eventually gets there. A lot of times in the Sahara Desert, they have big dust storms. Some of that dust, the heavier particles, do land back on the ground, but some of that dust is so light that it can stay in the air and just sit there and fly around in the air in the wind. Same thing with salt particles. They're so light that they remain suspended in the air. And then, again, remember, these are very, very tiny particles. We can't see these particles with our eyes. They're so small. And then these tiny little water droplets then will cling to these dust, dirt particles, and salt particles. And then once they all start to form together, that's when we can start to see the clouds. So when you're looking at a cloud, you're looking at water droplets with some dirt or salt in it. Or if it's cold enough, you're looking at ice crystals.
Emma would like to know, how do clouds go toward the ground?
Emma wants to know, how do clouds go to the ground? Well, basically, again, it's kind of has to deal with what kind of weather situation. So in the terms of like fog, when you're actually walking in a cloud, it's when, as we've talked about before, the water vapor, the gas, if it cools enough, if the temperature cools enough, then that gas turns into liquid. Tiny, tiny, tiny little water droplets. So that is what the fog is tiny little water droplets. So it kind of depends on the temperature. Now, obviously, if the clouds are a little bit higher, that means the water vapor is around us, but as that water vapor, that water gas starts to rise, it comes in contact with colder temperatures in the sky or above us, and then kind of the same formation. The tiny little water droplets will start to form, and then you have a cloud. So it all kind of depends on what the temperature is and what level it is where that cloud can start to form. So again, it's a lot of variable questions when it comes to weather, a lot of variable situations.
Stephanie would like to know, how do you know which cloud is which? So basically the different levels of the atmosphere.
Yes, Stephanie wants to know, how do we know which clouds are which? And it's just something that we've studied. You know, meteorologists have studied the sky, and we've looked at all kinds of cloud charts. You can probably get a cloud chart. You can probably go online and look at cloud charts. There's all kinds of great stuff from the National Weather Service. But basically, we learn to identify what they look like. We know what the low clouds look like, the stratus clouds. We know that the cirrus clouds kind of look like maybe a lock of hair as it's described, or just kind of wispy. Sometimes they look like maybe a horse's tail, the clouds. The cirrus clouds. The cirrostratus clouds, as I told you about, the sun can actually shine through that, kind of filter through. Altocumulus clouds, they're a little bit lower, and so they're a little bit, they might be a little bit bigger, they might be a little thicker, so the sun might not shine through that. So we just kind of learn by looking at the types of clouds to identify them, and you can do that as well. You get a cloud chart, and you look at the cloud chart, you go outside, you look at the sky, and you say, okay, what do these clouds look like? And then you go to the chart, and you say, I think these are the altocumulus clouds. And then eventually, after you look at them long enough, you can look at the sky and you can figure it out for yourself what types of clouds are out there.
Carter would like to know, why do clouds turn gray before a storm?
All right. Carter wants to know why clouds turn gray before a storm. It really has to do with light. A lot of times when the sun is out, you see basically white clouds, kind of like the cumulus clouds here. But when you don't have sunshine, when the sun is obscured by higher clouds or clouds in a different area, they look very gray. We're not getting enough light. So that's why they appear gray, is because there's less sunlight coming into the area. So that's why they're gray, or they look white if the sun is shining on them. So hopefully that answered that question there.
And Kaylee would like to know, why are clouds so heavy?
All right, Kaylee wants to know why clouds are so heavy. And basically, there's a lot of little tiny water droplets in there, millions and millions of tiny little water droplets. So basically, different clouds weigh different amounts. But when we just talk about a cumulus cloud, just one of those big puffy cumulus clouds that you see, like the cotton ball type clouds, there's so much water in there. There's so many tiny, tiny water droplets. If you were actually able to weigh it, it would weigh over 1 million pounds, which would be about the same as 100 elephants. that's pretty impressive.
That is very impressive. About it. We've got Avery, who would like to know if airplanes can fly through all types of clouds.
Avery wants to know if airplanes can fly through all types of clouds. And the answer is yes, they can, but there are clouds that they want to avoid. They do not like to fly through thunderstorms, just because thunderstorms can be so turbulent with up and down air movements, and there can be hail, there can be lightning. So yes, airplanes do avoid clouds with a lot of lightning, or basically thunderstorms. So they try to avoid that. They also don't like fog. Airplanes have a hard time. They can't see the runway. The pilots can't see the runway. So a lot of times, if it's really foggy in an airport, your flight might be delayed until that fog lifts, because you can't see the air, you can't see where to land in that fog. So that's another thing where clouds can cause problems. Also, they do try to avoid clouds that might have a lot of ice in it, just because they don't want the ice to cling to the airplane wings. So there are some clouds that the pilots will try to avoid, but most clouds, again, that are made of water vapor, or I should say water droplets, they can fly right through without any problems.
All right, got time for one more, I think. Here.
All right, one more question.
So we'll end on a fun one here, Brad.
Okay.
I've been wondering this myself. Elise wants to know, how do clouds get shaped like animals?
That is a great question. I like that. I think a lot of it has to do, of course, with the wind shaping the clouds, but it also has a lot to do with a person's imagination. You look at a cloud and you can obviously see pictures. So however the wind develops, whatever you're thinking about, whatever your imagination might be, that's why we see pictures in the clouds, and that is certainly a lot of fun. So that was a great question. Just a couple other things that you might be interested in before we say goodbye on this one. Just in case you want to know how many sunny days Lincoln has on average, that means without any clouds, we average 214 days a year with sunshine. So that's mainly sunny skies. That's the average for Lincoln. For the entire state of Nebraska, we actually average 223 sunny days. So 61% of the days of the year in Lincoln are sunny, so 214. So that we live in a sunnier climate than we do a cloudier climate. If you lived in a place like Seattle, it'd probably be a lot different. There'd be a lot more cloudy days than sunny days. But here in Lincoln, as well as Nebraska, we have more sunny days than cloudy days. So that is it. I believe Kid Shimmick on Tuesday will be talking about precipitation types. And, we've already talked about the clouds. We've talked about rain, but we're going to go in more depth with rain and hail and snow and sleet. So that's going to be next Tuesday's topic. So once again, thank you very much for joining us again. Hope you got something. If you have other questions and we didn't get to your questions, we will answer them on Facebook, but feel free to ask questions beyond this workshop, and we'll try to get back with an answer. So thank you very much for joining another 1011 workshop. Thank you, Allo, and thanks for joining us. So until Tuesday.